Okay, so let's get through some angle basics here as far as vocabulary goes. You'll see on my screen that I have some definitions typed in here. These are not currently on your guided notes, so as we go through you'll probably need to pause so you can jot some of these definitions down, because I will also be adding the examples along with them. So, first things first, let's talk about what an angle is. An angle is a figure formed by two rays. The key to this is going to be how we actually name an angle and the different ways in which we can do that. As you can see on the picture above, we have a bunch of points labeled A through, I guess, H. And then we also have a bunch of numbers, okay? You can name an angle using either points that make up that angle or numbers if those numbers are provided to you. So for instance, if you wanted to name this angle right here, from here over to here, these are both rays, right? So you have two rays, they're going in opposite direction, or they meet at a point. We can call that angle that I just highlighted angle 9, because 9 is on the interior of those two rays. So one way we could name that angle would be to call it angle 9. Or the other way we could name it would be using the 3 points that make up that angle. Okay, and by 3 points I mean F, which is a point on this ray, G, which is the point where the two rays meet, and H, which is a point on the other ray. You need to use all 3 points, and the G has to be in the middle. So in this case we would call this point, or this angle, angle F G H, or we could call it angle H G F, as long as the G is in the middle. So those are the two ways you can name angles. You can either name them using 3 letters, or you can use them using the number that's on the interior of the angle if a number is given to you. Sometimes a number isn't even a possibility because it won't be given to you. Okay, second thing we'll talk about here is the vertex. The vertex is that actual point where the two rays intersect. In this particular example, that would be point G, okay, because that's the point where the two angles, or the two rays intersect. That's called a vertex. Alright, let's keep going. An acute angle. Acute is an angle with a measure less than 90 degrees. Okay, this is your less than sign, in case you're not up on your inequalities. Alright, so there's a couple angles up here that we could identify as being less than 90 degrees. One thing that you may or may not know is when you see this little box-shaped thing, that denotes a 90-degree angle. So that entire thing is 90. So we can see here that either angle 7 or angle 8, those both must be less than 90 degrees, because together they make 90 degrees. So in this case, we could call angle 7 an acute angle. An angle with a measure of 90 degrees is a right angle. So as we go back up here, I see where I have that red box that I have a 90-degree angle. Okay? The problem is I don't have a point. I see now I need another point up here so that I can actually name that angle. Let's call this point I. Alright? So the actual angle that I'm looking at here, for the sake of naming a right angle, the actual angle would be from here up to here. Okay, that purple angle there, that's the right angle. And I can't name it as 7 plus 8. Okay, so I'm not going to use numbers this time. I'm going to use 3 letters. And the 3 letters, let me just kind of delete off that, and I'll use the blues again because I already have them on paper. Now the three letters that I'm using are H, G, and I. Okay, you have a letter on one ray, you have the vertex, and you have a letter that's on the other ray. HGI or IGH. It's up to you which way you want to name that. I'm going to call it HGI. Angle HGI. Or you could use IGH, as long as the G is in the middle. Okay? And then lastly, we have an obtuse angle, which is when the degree measure is greater than 90 degrees. Okay? So as I go up here, I'm looking for an angle that's greater than 90 degrees. Probably your best bet would be something like angle 5. Okay, you have this angle right here that goes from here. Now a 90 would be straight up like this, but this is not a 90. It's bigger than 90. So as you come in and you go up here, that angle right there would be obtuse. It would be bigger than 90 degrees. So in that case, you are allowed to name that angle 5 if you wish. Or you could use like GDA or ADG would also work. I'm just going to call it angle 5 because, you know, when I have a number that I'm allowed to use, I might as well use a number that's going to be the easier way to go. Okay, moving forward, adjacent angles. These are angles that have a common side. Okay, another way you can think of adjacent is to say they are next to each other. So as I go up to the top here, I'm looking for two angles that are next to each other. I think a good pair would be angles 7 and 8. Okay, angle 7 and angle 8 share this side. Okay, they're right next to each other, 7 and 8. So I'm going to go down here. Now there are others. Obviously you could use 1 and 5, 1 and 2, 2 and 3, 3 and 4. Any pair that share a side and are next to each other we call adjacent angles. Angle 7 and angle 8 are adjacent. Now vertical angles are a little bit more particular in that they share a vertex, but they do not share a side. And a big thing about these is that vertical angles are congruent. Vertical angles are congruent. Vertical angles are congruent. You got to get that in your head because you're going to see that a lot this year. Vertical angles are congruent. So as I go up here and I look for a pair of those, I'm looking for two angles, share a vertex, do not share any sides, and are congruent. I'm going to go back to that angle 5 that we just talked about, and I'm going to look at angle 2. Notice that these two angles share the exact same vertex, which would be point D. They are across from each other, and because of the lines that they share, meaning this line and this line, we know that those opposite angles are congruent, hence vertical angles. So angle 2 and angle 5, angle 2 and angle 5 are considered vertical angles. Angle 2 and angle 5. Okay. Continuing along, linear pair. Linear pair are adjacent angles that add to 180 degrees. Linear pair, okay, or line pair, a pair that make up a line. So in a case where you're looking at this line right here, you can see that angles 1 and 5, when you add them together, starting from this side and going over to here, those two angles together make up that straight line. Therefore, they are a linear pair. Linear pair, angles 1 and 5. All right, perpendicular lines, two lines that intersect at a 90. Two lines that intersect at a 90. Well, in this case, the only 90-degree angle that we see on our entire picture is this 90-degree angle right here. All right. So, if I kind of go over to the side and show how that 90-degree angle was made up, I have point I up here, I have point H over here, this is point G, there's also other stuff to the left and to the right, but if I were to name the two lines that make up this 90, I would call one of them GI, okay, which I would have to note that this way, because it's an endpoint, but it goes on this way. And the other one I would have to call GH. Now, because there are arrows at both ends of GH, there's an arrow here, and way over here, there's also an arrow. I'll denote that one that way. So you have GI and GH. Those are the two lines, GI and GH. Okay. Congruent angles are angles of the same measure. And remember that these little notch marks here, these little notch marks mean congruent. So angles 3 and angles 4 are congruent up there on our picture. You cannot just assume that angles are congruent because they look congruent. For instance, angles 7 and 8, a lot of people would try to say angles 7 and 8 are congruent. Well, we don't know that. They kind of look like they might be, but without the notch marks there, we are assuming something that we don't know to be true. Okay? An angle bisector is a ray that cuts the angle into two congruent angles. So if we go back up to where 3 and 4 are, and this ray right here is considered an angle bisector because it takes that bigger angle, cuts it into two equal angles, angles 3 and 4. So the actual angle bisector, once again, looks like I need another letter here in order to name this thing. Let's put a J here. We'll call that ray DJ, because the end is D, I go through J. So in this case, that ray is DJ going that way. All right, two more. Complementary angles are two angles that add to 90 degrees. So let's go back up here. You see that 7 and 8, once again, they make up this 90-degree angle. Since they add to give me 90, angle 7 and angle 8 would be considered complementary angles. They add to 90 degrees. Supplementary angles are two that add to 180. Well, if I go back up here, remember that we did our linear pair over here. And the definition of linear pair is two angles that add to make up a line. Well, a line is 180 degrees. So angles 1 and 5, once again, we use those for a linear pair, but 1 and 5 can also be used as our supplementary angles, two angles that add to 180.